So, defining a recurrence relation, this is our new topic. A recurrence relation describes a sequence in which each term is a function of the previous terms. So our notation, our starting value, u0, v0, g0, I've used u. Our first term is u1, our second term is u2, our third term would be u3, u4, u5, and the nth term, you've heard the nth term formula in S1 and S2, the nth term is un. So a sequence defined by un add 1 is aun plus b. You'll notice this value is n add 1 and this is n. So if this was 2, this would be 3. If this was 1, this would be 2. If this was 10, this would be 11, and so on, because n we can substitute different numbers in for. So if we've got the 10th term here, we're working out the 11th term. It's the 12th term here, it's the 13th term here, and so on. So looking at our first example, the sequence is defined by the recurrence relation un add 1 equals 0.8 un add 20, with u0 being 40. So our initial term is 40. So we want to calculate the value of u3, and we want to find the smallest value of n, i.e. the smallest value here, for which un is greater than 90, basically when it goes over 90. So what we've got is we've got our recurrence relation un add 1 equals 0.8 un add 20, with u0 is 40. So u1 will be 0.8 u0, which is 40, add 20, which gives us 52. u2 will be 0.8 u1, which is 52, add 20. u3 will be 0.8 u2, add 20, which gives us 69.29. Now I'll show you the way to do this on a calculator. The way to do this on a normal scientific, you can do it on your phone, is to do 40 and hit the equals key, and then do 0.8 times ANS plus 20. When you press the equals key, you'll get 52. When you press the equals key again, you'll get 61.6. When you press the equals key again, you'll get 69.28. So u4, continuing on, I'm not going to keep saying it, I'll say it for this one, would be 0.8 u3, which is 69.28, add 20. u5, u6, u7, u8, u9. So u9, u8 is just below 90, u9 has gone over 90, so the smallest value that takes over 90 is when n equals 9. For a second example, for each recurrence relation, find the u5. So we've got un add 1 equals 2un minus 20, with u1 being 18. And the second one, we've got un minus 1.5, un minus 1. So here, you'll notice slightly different notation. If this is 10, 10 minus 1, that would be 9. So it's exactly the same, but rather than n add 1, we've got n take away 1 on the other side. And here, u1 is negative 4. So looking at the first one, we've got u1 is 18. So we're going to do two lots of 18 minus 20, which will give us 16. u3 will be two lots of 16 minus 20, which will be 12. u4 will be two lots of 12 minus 20, which will give us 4. And u5 will be two lots of 4 minus 20, which will give us negative 12. For the second one, un equals negative 1.5 un minus 1, where u1 is negative 4. So u2 will be negative 1.5 times negative 4, which is 6. u3 will be negative 1.5 times 6, which will be negative 9. u4 will be negative 1.5 times negative 9, which will be 13.5. And u5 will be negative 1.5 times 13.5, which will be negative 20.25. And that's the questions we're doing, but I'll put them up.